Okay, let's solve some more problems. 4x square y minus x plus y times y minus 2 x minus y equal to 4x plus 4y minus 7. Let's simplify this. 4x square y minus 4x cube plus y square minus 2y x minus y minus 4x minus 4y plus 7 equal to 0. Okay, 4x square y minus 4x cube plus xy square minus y cube minus 2xy plus 2y square minus 4x minus 4y plus 7 equal to 0. Okay, now what we'll do is, remember here the sum of the exponents is 3. So let's group such terms together. 3, 3, 3, 3. So this is 1. 2, 2. So this is another group, this is another group. Okay. So now let's substitute x equal to 1 and y is equal to m. So when we do that, what happens? 4, x is 1, so m minus 4 plus m square minus m cube minus 2m plus 2m square minus 4 minus 4m plus 7 equal to 0. Again, remember, this is together, and this is together. Okay, don't simplify it. Don't simplify by adding this 4m to this negative 4m. Don't do that. Okay, now remember, 3 is equal to minus m cube plus m square plus 4m minus 4. Okay, now we need to equate this to 0. So let's say equal to 0. Now we have to solve it. So here m square if we take. Okay, now let's do one thing. Let's multiply this entire thing by minus 1. So what happens? M cube minus m square minus 4m plus 4 equal to 0. So now m square, m minus 1 minus 4, m minus 1 equal to 0. So which means m square minus 4 times m minus 1 equal to 0. M square minus 4 equal to 0, or m minus 1 equal to 0, m equal to 1. Now here m minus 2, here m minus 2, m minus plus 2 equal to 0. So m equal to plus or minus 2. So these are the roots or the slopes of asymptotes are 1 plus 2 minus 2. Okay, now we have the slopes. Now what we have to figure out is the y-intercept, and the expression for that is phi n minus 1 of m by phi n prime of m. Okay, so remember, phi 3 is equal to minus m cube plus m square minus 4m plus 4m minus 4. So phi 3 prime is equal to minus 3m square plus 2m plus 4. So now let's calculate the y-intercept. Minus phi n minus 1 m. Phi n minus 1 is phi 2. Now phi 2 is equal to what? Phi 2 is equal to minus 2m plus 2m square. So minus 2m plus 2m square, and there is a separate minus of the expression itself. Okay. Now what we can do is cancel this by changing the sign. This is what? Minus 3m square plus 2m plus 4. So this is equal to 2m minus 2m square by minus 3m square plus 2m plus 4. Okay. Now what we are going to do is this is the expression for the intercept. We are going to substitute the values of m to get the intercept for the respective slopes. Okay, so for m equal to 1, c is equal to 2 minus 2. See, the moment we do that, we don't have to evaluate the denominator. So equal to 0. Okay, for m equal to 2, c is equal to 2 times 2 is 4 minus 2 times 2 square is 8 by minus 3 times 2 square is 4 plus 2 times 2 is 4 plus 4. So minus 4 by minus 12 plus 8, which is minus 4 by minus 4, which is 1. Okay. For m equal to minus 2, c will be equal to 2m. That is minus 4 minus 8. Because of m square, minus will disappear. Minus 3 times 4 minus 4 plus 4. So these two gets cancelled. Minus 12 by minus 12, which is 1. So which means the asymptotes are y is equal to, now here what is the slope? In this case, slope is 1 and intercept is 0. So x. In the second case, y is equal to 2x plus 1. In the third case, minus 2x plus 1. That's the equation of the asymptotes. Now let's look at it in GeoGebra. This is the graph of our equation. Okay, let's ask it to display the asymptotes of A. So here you have 1, 2, 3 oblique asymptotes. Let's specify our own equations that we had arrived at. Y is equal to x exactly on top of each other. Okay, then the second equation is y is equal to 2x plus 1. Yes, exactly on top of each other. And the third was y is equal to minus 2x plus 1. Okay, so that solution is correct. Okay, let's look at the second one. X cube minus x square y minus xy square plus y cube plus 2x square minus 4y square plus 2xy plus x plus y plus 1 equal to 0. It's already nicely grouped together. Okay, now highest power of x is x cube. No coefficient, right? Similarly, highest power of y is y cube. Again, no coefficient, which means no asymptotes parallel to xy axis. Okay. Okay, so which means there will be oblique asymptotes. Maybe, we don't know. Let's see. So let's say x equal to 1 and y equal to m. Now let's substitute it. X equal to 1. So 1 minus m square plus m cube. Okay. This is going to be phi 3 of m. Phi 2 of m would be equal to what? It will be 2 minus 4m square plus 2m. Okay. We don't really require phi 3 of m since I've already written it. So let me just 1 plus m. Okay, now we may also require this. So let's write it off. 3m square minus 2m minus 1. Now as we go along, whatever we require, we'll evaluate it. Now we need to take this and equate it to 0. So m cube minus m square minus m plus 1 equal to 0, which means m square is common. So m minus 1 minus 1, m minus 1 equal to 0. M square minus 1 equal to 0, m equal to 1. So which means m is equal to plus or minus 1. So that means m is equal to 1 comma 1 comma minus 1. That means there are repeated roots. Okay. So first let's take care of the unique root. So y-intercept is phi n minus 1, remember, divided by phi n prime of m, which is equal to, now phi 2 is what? Phi 2 is minus 4m square minus 4m square plus 2m plus 2 by 3m square minus 2m minus 1. Now for m equal to minus 1, which is a unique, c is equal to what? Minus 4 minus 2 plus 2 by 3 plus 2 minus 1, which would be minus 6 plus 2. Okay, these two gets cancelled. So minus 4 by 5 minus 1 is 4, which is equal to 4 by 4, which is 1. So the one of the asymptotes would be where the slope is minus 1 and y-intercept equal to 1, which means y is equal to minus x plus 1. Or we can say y plus x minus 1 equal to 0. Okay, now what about repeated values? So for repeated values of m, that is 1 comma 1. Now for that we have to evaluate this c square by 2 double prime of m plus c phi n minus 1 prime of m plus phi n minus 2 of m equal to 0. Now phi n, that is phi 3. Now let's take phi 3. Now phi 3 double prime of m is equal to what? Remember, we have already differentiated it and we have got 3m square minus 2m minus 1, right? So this is our first derivative. So which means double derivative would be what? Second derivative would be what? 6m minus 2. Phi 2 derivative would be what? Now phi 2 is what? Phi 2 is minus 4m square plus 2m plus 2. So which means derivative of that would be minus 8m plus 2. Let's do the substitution. So c square by 2. This would be 2 times 3m minus 1. Let's take minus 2. So this becomes 4m plus 1. And phi 1 is 1 plus m. So 1 plus m equal to 0. Okay. Now this gets cancelled. See, now we can actually substitute because we know m is the repeated values 1. So c square 3 times 1 is 3 minus 1 minus 2. 4 times 1 is 4 plus 1 plus 1 plus 1 is okay. Now here again we have c. I missed out c. So 2c, 2c. Okay. So this comes to what? 2c square minus 4 plus 1, 5. 5 to the 10. Now see, made a mistake. Here it is going to be, this is plus 5. But the thing is we have taken minus out. So this should become minus. So that overall it is plus. So this should also be minus. Okay. So now what happens? 2c times 3 plus 2 equal to 0. And divide the entire equation by 2. So this becomes c square minus 3c plus 1 equal to 0. Okay, so let's solve this quadratic equation. This becomes c is equal to minus 3 plus or minus square root of b square is 9 minus 4ac, 4 times 1 times 1, so 4 divided by 2a, so that is 2. 6, no, not 6, 3 plus or minus square root of 5 by 2. Y plus x minus 1 equal to 0. So the other one is y is equal to 3 plus root, no, this is the y-intercept. M is what? 1. So x plus 3 plus root 5 by 2. And the third is x minus 3 plus root 5. No, minus, this is plus, minus by 2. Okay, this is the graph. And let's ask it to display the asymptotes, right? So here you have one asymptote and two parallel, parallel to each other. Okay, let's specify the equations that we had derived. The asymptotes that we had identified: y plus x minus 1 equal to 0, exactly on top of each other. Y is equal to x plus 3 plus square root of 5 by 2. Again, y is equal to x plus 3 minus square root of 5 by 2. That should have been outside that. So by 2. So exactly on top of each other. So our solution is correct. That's enough for today. Bye for now.